Hello, everyone. So we are now 2025 AIME 1, problem number 7. So we are given 12 letters, okay, A through L, and randomly grouped into 6 pairs of letters, and the 2 letters in each pair are placed next to each other in alphabetical order to form 6 2-letter words, okay? And then those 6 words are listed alphabetically as well. For example, like when you take the 2 letters, let's A and B, A has to come first, B after, so that's why A before B. And then in the same reasoning, like H comes before I, so that's why HI is in the given order. And that's one restriction. And the second, we need to get like the early letters before the next ones in the order. So like A before C, C before D, E before L, F and stuff like that. So, and this is the example. So based on this, we want to find the probability that the last word listed contain G is what we are interested. Okay, so like it's kind of hard to kind of start with. So let me say, let's say these are the our 2-letter words. Okay, so we have 6, and then now it's 10. So like 2, 4, 6, 8, 10, 12. Okay. So your G might be the first letter of the last word or the second letter. So which is why we're going to do kind of 2 cases. So let's say this is case number 1. Okay. So let's say the G is the last one. So let's say this is G. And then we want to finish the rest. Like we already know these are my letters, right? So A through L. And since we know that the G was used already, and I like to have like 6 letters that will be coming the first letters of each 2-letter words, right? So then when you look at the listing, so A through F, we have already 6 of these. That means A through F should be the first letters. So then let's say if I want to kind of start with that idea, but at the same time, we do have actually the restriction, like where we do need to get A, B, C, D, F from left to right. So that will force F to be actually in this location. So which means F actually is going to be here. So, but to get this position, like I'll kind of try to take the probability of being that F to be. So like we had like 11 other letters, and then only one is actually working for this spot is F. So we do have actually 1/11 probability for this last 2-letter words is the FG. Okay, so I hope that's clear. And then maybe I should write the like name anyway. So the second one is I'll remove this as well. So I want to get the maybe from left because I kind of want to start from the A's and then all the way to the end. So like let's say we want to say this is A, right? So if this is A, so then the second could be any of these lists, not the first list, because we know that these guys has to be our first letters. And if A is the first letter, then I should choose one of these for the second spot. So we can have 1, 2, 3, 4, 5. So we have 5 options for the second slot that we can pair with A. So that is 5 out of 9 because we already chose this one, and then we have 5 available. That is okay, and then we have 4 more in this list as well. So 5/9. So this is basically for A to H, for example. Like I'm gonna choose H, but it doesn't have to be H. It could be I, A, J, K, or L. I know these 4 does work, but I'm gonna go with the kind of in this given order. So let's assume this is AH. Okay, that's the 5/9 probability. So now let's go with B. Okay, so I need to pair with this, and then H is gone. So B will be paired with one of these, so like 4. So we have 1, 2, 3, 4. So we have 4 options, and then that is available. That is can be used, and then we cannot choose these 3. So which means 4/7 is actually not good. And then I'll say this is gonna be like maybe BI. Maybe I can go with that. Okay, but again, these letters might be swapped, which doesn't matter. So as long as we are knowing they are not the fixed ones. And the next one is going to be C. So I'm going to remove these. If I want to choose C for this slot, then I can choose JKL, which is 3 options. And as you see, these are decreasing by 1 because you're just going through that way, that list. And then the denominators are decreasing by 2 because we are just crossing 2 lists in total. So that will be like 5. And then we have 1, 2, 3, and then 2 more. So J is gone now. Okay, so I'll just say C and J will be paired. And the next one is going to be D. If I want to go with D, okay, so I can pair with one of these 2, which is 2 choices, is desired outcome out of 3. So that is good. And the last one, E, will be, and then this D was K, and then E will be paired with L, and then we will be done. So that's just 100%. So that is the first case, right? So the second case is slightly different, but let's see how that's going to be different. So second case, I'll just say 1, 2, 4, 6, 8, 10, and 12. So like second case, the G is not the second, maybe first letter. So let's say this is G. So in that case, maybe I should write these one more time. So, but I can actually take these. So like we use now G, but the thing is we have like 1, 2, 3, 4, 5, 6 of these letters that is like kind of lower than G, which means can be used the slot for the first for each 2-letter words. But we already use one of them, so we just have 5 other options, which is like kind of we need to choose what 5 goes into those. You can kind of try combination stuff, but instead of kind of considering the first ones, I'll actually consider the second letters in each 2-letter words. So for example, I want to find the whatever is available for this slot, like that's gonna be kind of my way to go. So if this is like a G, right? So and then next has to be a high level letter, which means I can choose one of these. So it doesn't matter which one I choose. I'm gonna go with H. Okay, so that is gonna be, let's say 1. But the thing is, it could be H, I, J, K, or L. So which means we have 1, 2, 3, 4, 5 available letters for this slide. So that's going to be 5 out of 11. Okay, so that's this guy. So now I can start with the ABCs, whatever. So like if I want to go with my A first, let's say I'm going to choose this as to be, let's say A. Actually, maybe I should go with I instead. So I'm not sure if I want to go with A now. So like if I want to go with like I, because that's the second letter in the high level letters, right? If I want to go with I for the one of these, so which doesn't like look like too different from the first approach, but let's say I is the second one, and then we do need to choose the first letter, right? So like, and then we know that I can be paired with any of these, which means that we have 6 available letters. So for that one, so which is why 6 over, and then we can pair I with one of these 6, but not the other 3. So in total we have 9. So that is not good. So let's say we did pair with A, okay, just to simplify. So if I go with that, that means that will be like A and I. So it doesn't have to be A, but you could do that. Okay, so now we do have that. And the next one is the J. So like if I have J, right? So if this is J, then you are going to pair with the one of the remaining ones. 1, 2, 3, 4, 5. So let's take this to be paired. So which I'm going to pair with one of these. Let's go with B. So that means that will give us B and J, to be simple. And then out of 7, because we already used 2, and that will be for the J. And now we are done with J as well as B. So now we are doing the K. So the same reasoning, I can choose one of the 1, 2, 3, 4 available slot. Let's go with C, so which is CK, and that means we do have 4 over 5. So that is my next one. And for the L, I can choose anything, right? So that will be like 3 available option, and out of 3, which is 100%. So we just can write as 3 over 3 or just 1, which is reasonable. Like when you are not sure at some point, we can sometimes check the numbers are decreasing by 1 in numerator, but the denominator is decreasing by 2 because you are using 2 every time. And then your numerator is decreasing by 1 because you're just decreasing what is available by 1 every time. And the same story going on here as well. So the rest just adding these 2 cases together, and that will be our answer. So like we can do some sort of simplification, I guess. So you can just do either way you like. I'm going to at least cancel these guys, and then these guys will cancel, so we can have no 3 at least. And we have 5 right here and 5 right here. Maybe I should cancel these as well. So these 5s will cancel. I don't want to cancel everything immediately because I just want to get the same denominator when I do multiply. So we have like 11, there is no cancellation. 7, no. 9 has something, but in this case, there is no other numerator to cancel. Okay, I'm going to go with this. So 4 times 3 is like 8. Okay, and then 5, 6, 4, that's 20 times 6 will be 120. And then denominator should be like 9 times 7 and 11. So I just swapped order, and that will be 128 over, so 9 times 77. Okay, so 9, 7 is 63, so that will give us 6, and 63 plus 3 will be 6, and 63 plus 6 will be 69. So that should be our answer. So we just need to get these to be simplified, and since you know the numerator is just 128, which is power of 2, and denominator doesn't have any like 2's, so which is why this is actually the simplest version, and we need to add those guys, 128 and 693. So that is 821. So the question was, to be honest, fairly challenging. But at the same time, when you look at the work that we do on this, at least, it doesn't look like too challenging. So only thing is, it's hard to kind of start with. So I recommend to like kind of explore a bit and just and see if that's gonna help you to make a general approach, which we usually say constructive counting. So I think that would be a good approach. Anyway, I'll see you in the next video.